It is now 18 minutes after 8. It seems kind of like magic, but it's called stereolithography. You dream up an idea, plot it out on your computer, and then presto, out comes an exact model. As science editor Michael Gillen tells us, it's revolutionizing American industries.
Ever since the Industrial Revolution, we've learned to make things, lots of things, quickly and cheaply. Unfortunately, we're not as good at designing things quickly and cheaply. For example, the auto industry spends twice as much money designing car parts than they do making them. All that's about to change, though, thanks to a remarkable new invention called stereolithography. Here's how it works. Suppose you've just designed a new widget, in this case, a new and improved distributor cap for automobiles. Next, you'll want to make a prototype, a test widget, before going on into mass production. In the old days, the auto industry made test models out of clay, a process both expensive and time-consuming. But with stereolithography, this computer uses a laser beam to literally create an exact 3D replica of your design.
I think a good way to describe it is to call it a three-dimensional printer.
Charles Hall is the inventor of stereolithography.
In the broadest sense, you might say it does for engineering and manufacturing what the Xerox machine or the word processor, or both of those, do for the office environment.
In stereolithography, the solid object is created out of a pool of liquid plastic. The liquid plastic hardens wherever it is hit by the laser beam, so that as the laser beam traces out the design, the 3D model is created layer upon layer from the bottom up. Stereolithography is a boom to industry because a prototype that used to take months to make will now take just a few hours.
In business, in manufacturing, they have a design that they cannot evaluate it until they've made the prototype weeks down the road after the first design concept. And then they come to their meeting with the head of department, and he looks at it and he said, "That isn't what I meant." And they have to go back and spend all that effort. With our system, you get it the next morning, and the same group comes together that next morning.
Doctors at the UCLA Medical Center are thinking about using stereolithography for cosmetic surgery. For example, if this were my skull, I could ask the computer to redesign my jawbone, my cheekbones, my nose, my brow, whatever, and then at the push of a button, I could stand by and look at the new me rising above the liquid polymer. Stereolithography is now being used to design jewelry like these fancy rings, perfume bottles like this one recently made for Avon, and computer products like the outer casing of this Macintosh modem.
With stereolithography, we don't have to tool for prototypes. This product was made with no machining, no tooling, and no layout drawings for a machinist to read.
So does this make a big difference to Apple computers?
It helps us get products to market faster, and it also helps us make better products.
Stereolithography turns human ideas into something tangible, and its future applications are limited only by the human imagination.
Well, I think the technology is capable of what I call just-in-time manufacturing, which is what the world is trying to really do, which means that you would produce the part just as you needed it. Now, we're not there yet, and we've probably got 5 years or more of hard research and development, but think if we could make a whole car door in less than a minute without any tooling and change it by just changing the computer model. I think we would revolutionize the way industry works.
Boy, it'll really be interesting to see how scientists take this now and apply it in the future.